everyone. I'm Nisha, Content Marketing Manager at Lambda Test. Welcome to the third day of the TestMu Conference 2024. We have had an incredible journey over the past few days, and I'm glad you are here to wrap it up with us. Do share about your favorite session or snippets from the session on social media with the hashtag TestMuConf so that we can select winners and give away prizes. Please show us love and support on social media. Having said that, this session promises to be a thoughtful exploration of how some of the most enduring tools in our industry, like Selenium, GNU Make, Maven, and Bash, still play a vital role in modern software testing. Our speaker, Benjamin Bischoff, brings a wealth of experience as a test automation engineer at Trivago. His career has spanned from game development to building and maintaining Trivago's in house test frameworks. In this talk, he'll share examples of how these classic tools have solved real world problems, demonstrating their adaptability and reliability. By the end of this session, you'll gain a renewed appreciation for the tools you may already know and discover how they can still offer valuable solutions in today's evolving landscape. After the presentation, we'll open the floor for a Q&A session. Feel free to drop your questions in the chat as we go along, and we'll get to them at the end. Having said that, thank you so much, Benjamin, for joining us today. The stage is all yours. Please take it away.
All right. Hello, everyone in the whole wide world. It's very impressive how many of you are here. And I'm glad that I can be here too. So let's start with old tools, new tricks. Um, let's get me out of the way really quickly. I'm a test automation engineer at Trivago. I've been in IT for about 24 years, the first 15 as a developer. And then I slowly transitioned into the world of software development engineer in test and QA. So that's what I've been doing for the past 9 years. And also, I'm a clean code and software craftsmanship enthusiast. And this probably shines through here as well. Little disclaimer here, because it can be a controversial topic. These are my views, and of course, you can disagree and you should disagree. This is perfectly fine. And this is less about the how. So I will show you some tools, but this will not be the sole focus of this. But I will also tell you more about the why we chose certain tools. And don't get me wrong, I'm not against AI solutions. I'm not against any of the hyped testing solutions of today. And we're certainly trying them out. So let's start with the purpose. So, as developers and test automation engineers and people working in those fields, we are just confronted with a lot of different tools and technologies, and it's really, really hard to figure out what to use and how to use it. And by the way, this list is generated by AI, so there might be technologies in there that do not exist. The most important questions when you have this many tools to choose from is what is worth dealing with, and more importantly, what is not worth dealing with. And for that, let's look inside the developer's brain. And I think I can do that because I still consider myself a developer. But again, if you disagree, that's perfectly fine. We have the new is always better dilemma. I will actually talk a lot about different dilemmas in software development and software testing. And the question is new always better? Of course, developers love new things. Test automation engineers like myself love new things, new technologies. And of course, learning new things is absolutely crucial for your job, because this expands your arsenal of tools on your belt. It gives you new ideas, new approaches about different solutions you can use. And I found this dad joke that kind of fits. What do you do with 100 peaches? You eat what you can, and you can what you can't. It takes a little while to get that, but I think it fits here because you learn new tools, a lot of them. You use what you have to, and you just store everything else away for later. By the way, I love dad jokes. Old tools, on the other hand, they have this connotation of being outdated, maybe unmaintained, less cool, way more boring. And yes, I do get that. Whereas new tools have this innovative approach. They can have better integration possibilities. They get more support, more updates, and they give you a competitive edge all around. And to be frank, and I'm seeing that a lot, it just looks good on LinkedIn if you can say, I have used this cutting edge tool. And yes, I'm guilty of that as well. But we have to take a look at some misconceptions and biases concerning the choices of technologies as well. The first one is what I call the tutorial dilemma, because if you start with a new tool, with a new solution, you probably check out the documentation and a first tutorial, like getting started. But this only shows you the happy path. It doesn't show you what can go wrong. Also, you typically have a very small problem that you solve with a tutorial. It's very simple, and because it is so easy to implement yourself, it can lead to a false confidence. So that may lead to you saying, okay, this is very simple to use. Let's use it in production. If you want to have a better evaluation of a tool, you should do a proof of concept for sure. And it is absolutely crucial for a real evaluation of the tool in your special circumstances and setup. But this costs time and this costs resources to properly do that, especially if you have a lot of tools that you have to choose from. So you have to do a proof of concept for everything, for every single tool. But still, some problems only show up in a full-blown project later after the proof of concept, because the proof of concept is also a smaller scale. And I had this myself. Management might confuse it with a real implementation. Actually, a manager in a former job came to me and said, "This looks very good. So when can we ship it?" And he didn't understand that this was just a quick throwaway thing to check out if this tool was feasible for us. Also, you might have heard of the sunk cost fallacy. That means if you invest time and money and a lot of effort in learning and studying a new tool, it gives you this justification for commitment. That means the more you invest, the more likely it is that you want to use it. Otherwise, all this time, money, and effort is wasted. And this can be uh, dangerous because it can lead to irrational decisions. This one is a very well-known one. This is Maslow's hammer. It's from the Psychology of Science by Abraham Maslow, 1966. It's an old quote. I suppose it is tempting if the only tool you have is a hammer to treat everything as if it were a nail. So if this is the only tool, the only new tool you just learned, you want to use it for everything. The tractor factor, which is commonly known as the bus factor, but a colleague of mine called it the tractor factor, which I prefer. It's that if you are the only one knowing a new tool and you get run over by a tractor or a bus, then nobody has this knowledge. That means that either you have to know everything and accept that all the team members come to you to ask questions about it, or you have to teach the whole team. So you have to ask yourself, is it really worth using the tool if I am the only one in the know? And on the other side, you have this ambiguity effect. We are all human beings. We mistrust options we don't know. So if some team member comes to us and says, I have this shiny new tool, there is skepticism because it's something we don't know. And human beings have a preference for clear options to avoid uncertainty. So that brings us to chapter 3, which is about unknowns. And bear with me, it can be confusing, but I'll try my best to explain it. So it is generally said to find a tool or find the tool that fits your problem. But this is not easy. This is not something you just do and then you have the perfect solution. Because there are known and unknown unknowns. So a known unknown in software can be, if we have 10,000 requests per second for this API, I don't know what will happen, or 100,000 or 1 million. So you know that at some point something will go wrong in this setting. This is a known unknown. But there can also be unknown unknowns, like I had no idea that turning on this option in my tool would cause memory leaks. So something that you cannot anticipate, but that might happen. And Dan McKinsley had a presentation in 2015 about choosing boring technologies, and he said both sets, so he means the unknown unknowns and the known unknowns, are typically non-empty, even for tech that's existed for decades. But for shiny new technology, the magnitude of unknown unknowns is significantly larger. That means new tools that just hit the market have more unknown unknowns than old tools, of course. Yeah, find the tool that fits your problem. It's easier said than done, but it's important to know that your solution to a problem does not have to be a new tool. Because old tools, even though they can be boring and less cool, they can be more reliable. They are definitely more familiar. They can be way more compatible because they have been created in the past, so they're compatible with older solutions as well. They can be more cost effective because you don't need additional training. And you have a very, very large community in some cases, like the Selenium community. So Dan McKinsley again said about boring technologies, the nice thing about boringness is that the capabilities of these things are well understood. But more importantly, their failure modes are well understood. So let me try to give you an example here. I called it Back to the Future because, as you will see, we will go back in time. I will add more tools that are older and older to my tool stack, but we will move forward in the capabilities of the solution. So I created this task for myself, create a website test so I can use it locally and in a GitHub workflow. It's some typical things that test automation engineers might have to do. I chose a browser test because it's just a little more shiny and easier to demonstrate than an API test. So this, bear with me. Yes, I wrote a book. I wrote a book about the Karate framework for API testing. It's still the only book that exists on that framework. But this is not about the book. This is about my website that has a link to a sub page for this book. And this is the one I want to test. So I want to click on that link in my test and find the second headline and verify that it says what is this book about exactly. So that's what I want to do. And the first thing is I have to do something about browser automation. And my go-to tool is Selenium. If you ask Microsoft Copilot what Selenium is, it will say Selenium is a free open source automated testing framework used to validate web applications across different browsers and platforms. And you can easily see why AI solutions are not always good, because this is completely wrong. Selenium is not a test automation framework. Selenium automates browsers. That's it. So it's more like a remote control for a browser, and that is cool. So this is a timeline, and I I added myself here, so now you know how old I am. I am an old tool myself, and Selenium was established in 2004. So it actually had the 20-year anniversary this year. Same year as Spider-Man 2 came out, if you are old enough to remember. Just to give you a reference. So this is simple Selenium code that does exactly what I want. It's not a test yet. I put it in a Java main class just to run it. But if you have heard that Selenium is complicated, just check this. You create a WebDriver, in this case, a Chrome driver. Then you say, I want to go to this URL. And then you can find the element with a link text writing API tests with Karate. So the link that was clicked on in the small video, and then click on it. And then I want to find the element with the tag H2, which is the second headline, and get the text from it, and then do an assertion that this text equals what is this book about, and then quit the driver, which will close the browser window. So far, so good. By the way, if you didn't know, the newer version of Selenium downloads the drivers for you. You don't have to download the drivers or use the WebDriver manager. It's all built in. So here I run this test just from my IDE, and that's it. This is not running at double speed or something. This is the original speed. I start the test, the browser opens, it's done. So again, if people tell you that Selenium is slow, nope, it's not. It's actually very, very fast. Okay, let's build on top of that. Let's use Maven, another old tool. And Copilot says Maven is a software project management and comprehension tool that provides developers a complete build lifecycle framework. This is also not entirely correct, but I will show you what's cool about Maven. In the timeline, it is here. It's 2 years before Selenium. Same year that Spider-Man came out. That is a very interesting coincidence. All right, this is Maven, and Maven has an XML structure, and the power of Maven is that it has a software lifecycle built into it, so different phases of building and testing and deploying software. But what's really nice is dependency management. So in this case, I can just specify I want to use Selenium Java. In this case, I use version 4.18.1. There is a much newer one out there already that we're using in production, but for this demo, I stuck to the old one. Also, I pull in JUnit Jupyter, which is JUnit 5, so I can run this as a real unit test. And this is how you can run the tests with Maven when you implement them. Just Maven clean test, and it will just run your test. So this is what I did to the code I had before. So in this case, because we run the test now as a unit test, I can say before each test, create my WebDriver. So you will have a fresh browser window for every single test case. And after each test, automatically close the current browser. And this is essentially the same code I had before. The only difference is that I now use a real assertion here, but the rest of the code is exactly the same. Now, if we want to run this, we can just use Maven clean test as I showed you, and you see that now the test is equally fast, but it's executed via Maven. And you have all the power of Maven in your project as well. So far, we haven't really written a lot of code, but it's still doing a lot, I think. So Maven, I think, is really cool because of the easy dependency management. It greatly reduces duplication, because if you pull in other libraries that have dependencies themselves and they are the same as the core libraries, Maven will not download them twice, but it will manage those internally. It has a standard XML structure. I kind of like XML because it's machine readable and human readable. It's, by the way, from 1996, the XML standard. And you have very straightforward build and test flows. So it's very well defined what parts of Maven are executed in what order. And this is the thing, it does less. If you compare it to something like Gradle, Gradle is way more powerful than Maven, but this can be dangerous too, because if you can do less, you cannot do so many things wrong. So let's go even further back in time, but forward in our capabilities of this project. Use Bash. And Bash is an acronym for Born Again Shell. It's a command line interpreter that provides a user interface for various operating systems. In this case, Copilot is kind of correct. So you see that Bash is quite old, 1989. It's still younger than I am, but let's see if, if this holds up. Same year as Batman came out, 1989. So another superhero movie. I didn't plan this. It just came out like this. So let's add something to our project and do some WebDriver selection. So here we get a system variable called browser that we can pass to the project, and based on the value of this variable, we choose the WebDriver. So for example, if we pass Firefox, we create a Firefox driver. If we create Edge, we create an Edge driver. And those few lines give us multi-browser capabilities already. So you can actually run this now via Maven, just with this little change, by doing Maven clean test, and then with the -d, which is the option to pass a system property, you can do browser equals Firefox, and then this test will run with the Firefox browser. By the way, Selenium will also download the browser for you, not only the WebDriver. If you don't have Firefox on your system, after that you will have it. So this is a Bash script, and this Bash script is for the shell that I talked about. And we have the same command here as the Maven command. So this bash script actually executes the Maven command. The only change here is that we have the -d browser flag that I showed you before equals $1. And $1 is the first parameter we pass to the shell script. So you can actually run it like this. This shell script is called run tests.sh, and you just write Firefox as the second parameter, and then this is passed to the script, to the Maven command, and then it will run the test with Firefox. How this looks is this run test.sh Firefox, and then it says running tests with browser Firefox, and then this is Firefox. And you see that it's still super fast. It takes a little bit more time to spin up, but if you have many browser tests, it doesn't really matter because this overhead is only there once. Why Bash is great? It's the default shell in most Linux systems. Also, you have it on macOS. It has a very powerful scripting language. It has lots and lots and lots of built-in commands because it has all the Linux commands. And it has pipes and redirection. If you know a little bit about Bash, this is really cool because you can take the output of one of those Bash tools and pass it to the next tool. So you can actually chain commands together. But I'm not demonstrating it here because I wanted to keep it simple. Because the Unix philosophy is write programs that do one thing and do it well, write programs to work together. And that's why I like those tools. I like Bash, I like Maven, because they do one thing very, very well, and you can use them together. Now let's add the final one, which is Make. And Make, I consulted Wikipedia for this. Make is applicable to any process that involves executing arbitrary commands to transform a source file to a target result. It sounds very, very complicated, but it's actually not. It used to be used for C++ compilation, but it is so flexible that we can use it for anything, basically. In the timeline, finally, a tool that is older than I am, 1974. So it's 50 years old, and it has not really changed a lot. And there was not a superhero movie, so I had to choose Texas Chainsaw Massacre. Yeah, no comment. All right. This is what a Makefile can look, a simple one. So Make has so-called targets that you can define. We have a help target and a test target. The first target is automatically invoked if you just run make, then it will just pick the first. And the help target is just printing out a little bit of help, how to use it. And the test target, you see, is using the Maven command. In this case, is actually a bash command because Maven uses the shell commands internally. So we have make invoking a shell script, or not a shell script, but a bash command invoking a Maven command. So it's 3 layers, but I think it is rather straightforward. Also, you notice that we don't have the $1 as before, but we have a variable that we named browser. And this is it. This is a make variable. And this question mark equals means that if the user passes the browser variable, use this value, but if the user doesn't pass it, use the default, which is Chrome in this case. So this is how you can invoke it. Make test browser equals one of those browsers we support. And to see it in action, I invoke make. You see the help here. I invoke make test browser equals edge, and Selenium tests in edge. So this is the whole thing. And the cool thing here is that you can use this make command on a CI/CD system now. You can use it in GitHub Actions, you can use it on Jenkins. So it's rather easy with this setup to write something that you can use locally and in your build pipelines. Make, again, has a small number of features. It's available virtually anywhere. For Windows, there is an additional step to set it up. There are multiple ways to have Make on Windows. It's a very good entry point for tracing the execution flow of an application or of a test run, because the make targets can also be chained. So it's very easy to just look at a make file and see all the steps that are needed to build or test software. And it has a well-defined proxy for underlying technologies. As you saw, I used the make file to invoke um, a Maven command, so a Java command basically. But you can also use make to invoke PyTest or I don't know, JavaScript test frameworks. You can invoke whatever you want. You can invoke Playwright or Cypress or everything. But for the user of this make file, it will be make test in any case if you keep it consistent. And that's actually what we're doing here. We have make files that always have a test target or a deploy target or a build target. So it is easy to use for everyone, even though they might not have the knowledge about the underlying technologies. What about AI, you might ask? Because I showed you a lot of tools. The oldest one was 50 years old. Well, you might have seen this viral quote about AI from Joanna Maciejewska, trying to pronounce this name. I want AI to do my laundry and dishes so that I can do art and writing, not for AI to do my art and writing so that I can do my laundry and dishes. And this really resonated with me because I see it the same way. I test a lot of them, actually. This list is already outdated. I have been testing more of those solutions, also working with those more deeply. Um, and by now, I basically use AI solutions and LLMs daily. And they help you with things that you already familiar with. In this case, they speed up your work. But if you are not familiar with something, they tend to hallucinate and you will not see it because everything looks legit. So you have to have knowledge already to work with it effectively. So I always say I treat LLMs and AI like an extended rubber duck. So I give it my problem, I analyze the answer it gives me, then I give feedback, and then it's like a conversation. It's a little bit weird, but it works. And yeah, it also behaves like humans. So if you say please, it will give you better answers and so on. This image, by the way, was a test that we did um, for an older version of DALL-E. We said, please generate an image with men that have no beards and women that have beards. And it did not do it. Don't ask why we wanted that, but it just could not do it. But the key point here that I want to make is that AI knows way more about old tools because there is just more information about old tools on the net. It has more information about older tools and libraries. Many questions have already been answered. Like I said before, the failure modes are known, the known unknowns, the unknown unknowns, it's all covered. Many use cases have been covered, and this is why there's less chance of hallucination. So using AI with old tools can be very, very beneficial. And just as some final thoughts, be aware about biases. Not only when you interact with other humans, but also when you choose tools. Remember those biases like the sunk cost fallacy or the tractor factor or uh, the others that I showed you. Choose tools very, very carefully. It's always tempting to just after after a tutorial go for the shiny new tool and use it, but put a little more thought into it and more importantly understand the problem that you want to solve first. Don't let familiarity hold you back. I know we love learning, but if you know something already by heart, maybe you should use it and let this be a strength because you know all of the quirks of this tool. So you might be able to build a better solution with that. And for me, also very important, decouple progress from technology. Like I showed you, you can make a lot of progress by using older technology. So it doesn't mean that you can only move forward with your project if you use new things. And that's the point I wanted to make. And with this, I thank you very much for listening. I'm not quite sure how much time we have left, but if you have any questions, I'll try my best to answer them.
Thank you, Benjamin. That was a really insightful session. I'm sure our audience has gained valuable insights into how time tested tools can still be powerful assets in modern software testing. Also, I can see a lot of questions from the audience. I think we have some time to take up some questions. So let me just quickly display them. Okay, so
I can also read them out if you want.
yes, I
How
am reading them
can
out. How can teams maximize the value of time tested tools while incorporating them into agile or DevOps workflows?
um I would say do proofs of concept. We have a lot of experience if we want to choose a tool with just doing a lot of proofs of concepts at the same time to figure out what might be usable for us. Actually, through this, I discovered the karate framework because we had a proof of concept for an API test tool, and I said I don't like the karate framework. So we had a lot of different ways to do it. But then when I looked at what a colleague made with karate, I changed my mind because it ticked all the boxes for us. So also be open to choose another solution that you might not think is your preferred one. I don't know if this answers your question, but
Okay, let me take up the next one. What are some of the creative ways to extend the functionality of legacy testing tools to handle modern applications and architectures?
oh wow, that could be a great talk actually to creative ways to handle modern applications. Um, there are actually a lot of presentations also around Selenium, how to deal with uh, newer things like dynamic web pages and single page applications and also authentication. So uh, I cannot really go into detail, but most of the time, if you have older tools, you will find a way to deal with those things. And if you don't, that might be a reason to switch to a newer one. So, as much as I like using older tools, you shouldn't only use old tools if the problem you have is not easily handleable for those. if that makes sense.
That was a great answer. Let me take the other question. What are the best practices for integrating old tools into contemporary testing environments?
Also, not very easy to answer. They, first of all, they should be just runnable without too much overhead. So if something is not compatible with contemporary test environments, you shouldn't try to make it compatible by all means, but it should be supported. For this, containers are great. If you have older tools, you can also put them into specialized containers that support them. But I think the most important point here is to talk about that before you do it. To talk to talk about the other team members and people who have to use it. Because if they are not on board, then it doesn't make sense.
Right. Okay, we have a few more minutes. We can pick up one or two more questions. Oh, how have traditional testing tools evolved over time to meet modern testing needs?
Some haven't, but they don't need to. Um, but tools like Selenium that I showed you is now handling the WebDriver and browser downloads for you. That is making it much easier than before. Also, the Selenium BiDi standard that is being established at the moment. That is a huge step forward in bidirectional browser communication. Um, I'm sure you have seen things about that in this conference as well. But yeah, I mean, Selenium I'm especially fond of because I started with this and I still find it magical that it's just opening browsers and doing stuff. And I I really see that this is still advancing, but not forgetting the roots.
Okay, that brings us towards the end of this session. And I mean, really, thank you, Benjamin, for answering all those questions. This session was really, really informative. Also, I would like to remind all the attendees that all these sessions are recorded and will be available on Lambda Test's YouTube channel, so you can revisit them anytime and share them with your peers. Up next, we have a networking break. Feel free to join the fluid spaces to connect with like-minded people and continue the conversations. Thank you so much, everyone. Bye-bye and have a great day ahead.
Goodbye.